Tonight we explore the jagged edge of existence, standing on the precipice of a void that shouldn't be visible, yet glows with the light of 1 trillion doomed stars. For decades we treated the black hole as a ghost, a mathematical haunting in the equations of Einstein that we hoped we would never have to face head-on. We told ourselves that if they did exist, they were simply bottomless pits, cosmic sinkholes where matter went to die in silence. But we were wrong. The closer we looked, the more we realised that the darkness isn't just a hole. It is a predator with a physical presence, a monster that leaves a shadow on the very fabric of the universe. Imagine an object so massive that it doesn't just pull on you, it pulls on the light reflecting off your eyes, bending it, trapping it, and forcing it to orbit in a permanent screaming circle of fire. We used to think the event horizon was the most interesting part of a black hole, but we've recently discovered that the real nightmare, the true secret of our reality, is happening just millimeters outside that line of no return. It is a place where space is being pulled like a river, flowing at the speed of light, where magnetic fields act as sentient gatekeepers, and where the image of the black hole itself is a ghost, a visual lie told by the failure of physics. Chapter 1. The Ghost in the Lens. For a long time, the scientific community lived in a state of educated guesswork, possessing only the math to describe what a black hole must look like, because it was deemed nearly impossible to image an object from which light cannot escape. We were essentially trying to take a photograph of a shadow in a dark room, searching for a phantom that swallowed its own evidence. But on April 10th, 2019, the world changed when astronomers obtained the first ever image of a black hole located in the heart of the galaxy Messier 87. What we saw wasn't just a dark spot, it was a bright, terrifying halo of gas surrounding a central darkness that defied comprehension. This was M87 star, a monster measuring 24 billion miles across, 3 million times the size of our entire planet, with a mass 6.5 billion times that of our Sun. To capture this impossible image, we had to turn our own planet into a camera. Since a single telescope could never have the resolution to see something so distant, 53 million light-years away, we created the Event Horizon Telescope, a global network of synchronized dishes spanning from the South Pole to Spain, effectively creating a lens as large as the diameter of the Earth itself. This was more than a feat of engineering. It was a desperate attempt to look at the edge of reality. We weren't just looking at a hole, we were looking at the shadow of physics itself failing. When the image finally resolved, it revealed a ring of fire, a glowing accretion disk of plasma orbiting the abyss. But here is where the mystery begins to turn into a haunting. Why did we see a ring at all? If a black hole is a sphere of darkness, shouldn't it simply be a black ball? The answer lies in the ghost in the lens. The light we see in that iconic image isn't just coming from the sides of the black hole. It is light that has been violently warped by a gravitational field so strong it acts as a cosmic magnifying glass. Imagine the accretion disk, a celestial carousel of gas and dust swirling in a mesmerizing, violent dance. This disk rotates at nearly the speed of light, heated to millions of degrees by the sheer friction of matter being crushed into a smaller and smaller space. This heat creates a furnace that emits intense radiation, ultraviolets, X-rays and gamma rays that would blind a human observer instantly. In the M87 star image, we see this disk, but we are seeing it through a distorted funhouse mirror. Because the black hole's gravity is so immense, it causes light rays from behind the black hole to bend all the way around the sphere and into our eyes. We are seeing the top, the bottom, and the back of the disk all at once, smeared into a single circular glow. This is the ghost, a visual projection of a 3D nightmare flattened into a 2D ring of fire. But as we looked closer at this ring, we found something the original transcripts and news reports barely touched upon: the sentinel layer. New polarized images of M87 star have revealed powerful magnetic fields wrapping around the black hole's shadow, like a suit of armor. These aren't just stray forces of nature, they are the magnetic gatekeepers of the abyss. These polarized fields act as a high-energy barrier, a firewall that dictates the fate of everything that approaches the edge. This barrier is so extreme it can incinerate matter before it even touches the event horizon. This discovery introduces a disturbing implication that many overlooked. the black hole isn't just a passive eater, it is an active engine. These magnetic fields are what allow the black hole to chew on a star or gas cloud, and, instead of swallowing it, blast a portion of that matter back out into the universe as relativistic jets. These jets, moving at nearly a quarter of the speed of light, are transformed into quasars, the brightest objects in the known universe. The ghost in the lens is actually a mask for a machine of unimaginable power, one that uses magnetic sentinels to decide what is annihilated and what is launched across the cosmos to seed the building blocks of life in distant galaxies. The most haunting detail of all, however, is the shadow itself. In the centre of that ring of fire is a dark patch that we often call the black hole, but technically, that is the shadow of the event horizon. It is the place where light has no path left to reach us because every possible trajectory through space and time curves back in on itself. This is the point where the river of space begins to flow inward at the speed of light. Just outside this shadow, light can actually orbit the black hole in a perfect circle, creating a region known as the photon sphere. If you were to stand in this thin sliver of space, this interface between the world of the living and the world of the lost, you would experience the ultimate visual paradox. Because light is orbiting the black hole, if you looked straight ahead, the light reflecting off the back of your own head would travel all the way around the black hole and return to your eyes. You would be staring at yourself from behind, caught in a loop of trapped photons. This isn't just a fun fact of physics, it is a symptom of reality breaking down. We spent years looking for a hole in the universe, but what we finally found just outside the edge is much more terrifying. We found a 2D graveyard where the information of everything the black hole has ever consumed is encoded on its surface like a hard drive. We found a region where time begins to stop, where the ghost in the lens reveals that we aren't just looking at an object, but at the very boundary of human understanding. We are looking at a shadow that shouldn't be there, powered by a ring of fire that is merely a reflection of a deeper, unanswered mystery. That the outside of a black hole might be the only place where the true record of our universe actually survives. To understand what is happening just outside the abyss, we have to stop thinking of space as an empty room and start thinking of it as a physical material. For over a century, we've relied on Albert Einstein's revelation that space and time are not separate, distant concepts, but are instead woven together into a singular, flexible fabric called space-time. Imagine this fabric as a cosmic trampoline, stretched tight across the vacuum of the universe. If you place a small marble, like our Earth, onto that trampoline, it creates a tiny, almost imperceptible dimple. If you place a heavy bowling ball, like our Sun, the fabric curves significantly, and anything passing nearby like a planet naturally rolls into that curve. This is what we've always called gravity. But a black hole doesn't just curve the trampoline, it is so unimaginably heavy and dense that it distorts this fabric in the most extreme way possible. But here is the detail that most documentaries gloss over, the terrifying reality that exists in the thin sliver of space just before the no-return line. Space-time isn't just curved. Just outside the black hole, the fabric isn't sitting still. It is being violently pulled. Think back to that trampoline. Now imagine that instead of just sitting there, the fabric itself is being sucked through a tiny, invisible hole in the centre. The closer you get to that hole, the faster the fabric moves. This is the scissor of space-time. At this interface, the very stage upon which the universe performs is being shredded and pulled inward. Just outside the event horizon, space starts to behave less like a solid floor, and more like a river flowing toward a waterfall. This isn't a metaphor, it is a literal description of the physics at play. Einstein's equations tell us that gravity isn't just a force reaching out to grab you, it is the movement of the fabric of the universe itself. As you approach the edge, you are like a tiny fish swimming in a current. In the distance, the water is calm, but as you drift closer to the edge of the falls, the water begins to pick up speed. You can still swim against it, you can still escape, but it requires more and more energy the closer you get. In a black hole, this current of space is moving inward at a speed that increases the deeper you go. Just millimeters outside the event horizon, the river of space is flowing at nearly the speed of light. This is where physics fails. In our everyday lives, we think of space as a static background, a fixed grid where we can move left, right, up or down at our leisure. But just outside the black hole, that freedom is an illusion. You might have the most powerful rocket engines ever conceived, pointed directly away from the darkness, firing with the fury of a billion suns. From your perspective, you are moving forward at incredible speeds. But because the space you are standing on is being pulled backward into the black hole faster than you are moving forward, you are actually losing ground. You are doing the moonwalk on a treadmill, a cosmic exercise in futility where your velocity cannot overcome the speed at which reality itself is being withdrawn. This creates a localized region of absolute chaos. Because the tide of space is flowing so fast, it begins to scissor or shear anything that has the misfortune of being caught in it. If you were falling into a small black hole, you would feel this as a physical stretching. Because your feet would be just a few inches closer to the center than your head, they would be caught in a faster current of space than your upper body. The fabric of the universe would pull your lower half at a higher velocity than your top half, literally stretching your atoms into a long, thin string, a process physicists call spaghettification. However, in the supermassive giants like M87 star, this scissor effect is more subtle and more psychological. Because the black hole is so large, the river of space is vast and the difference in speed between your head and your feet is negligible. You could cross the interface and feel absolutely nothing. You would still be in freefall, floating as if you were on the International Space Station. But don't let that calm fool you. This is the most dangerous part of the scissor of space-time. Just because you can't feel the fabric tearing doesn't mean you aren't already lost. At the interface, the very concept of away begins to vanish. In the normal universe, you have 360 degrees of freedom. You can look in any direction and imagine a path that leads to safety. But as space begins to flow inward at the speed of light, the paths to the outside start to curve. Imagine trying to shine a flashlight to a friend waiting far away. Outside, the light travels in a straight line. But as the river speeds up, the light you try to shine away from the black hole gets caught in the current. It bends, it twists. Eventually, just millimeters above the horizon, every single path through space, no matter which way you turn, curves back toward the center. You are in a space traffic jam where every road leads to the same destination. This is the transition from a place where you have a future to a place where the singularity is your future. In the scissor of space-time, time and space effectively swap roles. Outside, you have no choice but to move forward in time. You can't stop tomorrow from coming. Inside the black hole's influence, the singularity, the center of the crush, is no longer a place you go to. It is a moment in your future that is as inevitable as Friday following Thursday. Trying to escape the black hole at this point is like trying to run away from tomorrow. It is a logical impossibility. This is the disturbing implication that most outlier videos ignore. The edge of a black hole isn't just a boundary of matter, it is the boundary of logic. We are used to a universe that obeys certain rules of cause and effect, where if you apply enough force, you can change your direction. But in the thin sliver of the interface, the scissor of space-time cuts those rules apart. It creates a region where the river of space is so powerful that it overrides the laws of motion. We used to believe that black holes were the end of the story, but the more we study this scissoring of the fabric, the more we realize it might be a beginning. Some theories suggest that when the fabric of space is pulled this violently, it doesn't just stretch, it might actually tear and connect to something else. Some believe that this river doesn't just lead to a dead end, but acts as a one-way wormhole that connects our universe to a white hole on the other side. If that is true, then the scissor of space-time isn't just destroying matter, it is acting as a cosmic loom, unspooling the fabric of our reality and reweaving it into a daughter universe. Standing just outside the edge, you are witnessing the ultimate act of cosmic recycling. You are watching the very coordinates of where and when being shredded by a gravitational tide that flows faster than light itself. You are standing in the one place in the universe where the trampoline isn't just vibrating, it is being pulled out from under your feet, leaving you to fall into a future where the only thing left is the darkness and the terrifying possibility that you are about to become the data for a whole new world. As we drift deeper into the gravitational well, we leave behind the physical tearing of the fabric of space and enter a realm that is perhaps even more unsettling, the domain where the very act of seeing becomes a lie. If the scissor of space-time was about the destruction of your body, this next region is about the annihilation of your perspective. We are approaching the photon sphere, a thin, ghostly shell of light that exists just outside the point of no return. To understand the photon sphere, you must first accept that light, the fastest and most elusive thing in our universe, is not as free as we think it is. We are taught that light always travels in a straight line, but in the presence of a black hole, straight is a relative term. Gravity is so intense here that it doesn't just pull on atoms and planets. It pulls on the massless particles of light themselves, curving their paths into impossible shapes. Imagine a beam of light passing near the black hole. At a distance, it might just curve slightly, a phenomenon we call gravitational lensing. But as that light gets closer, the curve tightens. Finally, at a precise distance, roughly 1.5 times the radius of the event horizon, the curve becomes a perfect circle. This is the photon sphere. It is a region where gravity is so perfectly balanced that light doesn't fall in and it doesn't escape. Instead, it enters a permanent screaming orbit around the abyss. It is a cosmic carousel of trapped photons, a place where light is essentially enslaved by the darkness. If you were to descend into this region, you wouldn't just be entering a place of high gravity, you would be entering the light that never left. The visual experience of standing within the photon sphere is the ultimate paradox of human perception. In our world, if you want to see something, light must bounce off an object and travel into your eyes. But here, the rules of optics are turned inside out. Because light is orbiting the black hole in a circle, the photons reflecting off the back of your own head would travel 360 degrees around the black hole and return directly to your eyes. If you stood perfectly still and looked straight ahead into the darkness, you wouldn't see the void. You would see yourself. You would be staring at the back of your own head as if you were looking through a window into the past. You are caught in a visual feedback loop, a symptom of reality breaking down where the distinction between in front of you and behind you has ceased to exist. But this is not a clear, perfect reflection. This is a funhouse mirror of the highest order. Because the black hole is spinning, a trait shared by almost all massive black holes like M87 star or Sagittarius A star, the light doesn't just orbit, it twists. This creates the ghost in the lens effect, where the image of the universe behind the black hole is smeared and warped around the central shadow. As you look out, you would see the stars of the Milky Way, not as distant points of light, but as brilliant curved streaks of blue and violet, compressed and intensified by the black hole's immense power. This is the phenomenon of aberration, where your extreme velocity and the curvature of space-time compress your entire field of vision into a bright, narrow circle in front of you. Even if you turned around to look at the outside world you left behind, the light from the stars would appear to be rushing toward you from the front. There is a haunting psychological weight to the photon sphere that most documentaries ignore. It is essentially a fossilized record of everything that has happened near the black hole for thousands of years. Because light can orbit here for a significant amount of time before finally falling in or escaping, the sphere acts as a 2D graveyard for photons. If a star exploded nearby 10,000 years ago, some of that light might still be circling the black hole, trapped in the photon sphere like a ghost. As you pass through, you aren't just seeing the universe as it is, you are seeing a scrambled, chaotic archive of its history. You are witnessing the end of reality before you even touch the horizon. The physics of this region is also incredibly unstable. Physicists describe the orbits in the photon sphere as dynamically unstable. This means that the slightest nudge, a single stray atom, or a tiny fluctuation in gravity will cause a photon to either spiral inward to its death or be flung out into the vacuum of space. It is a place of absolute precariousness. You are standing on a visual knife edge. To an observer watching from a safe distance, you would appear to be slowing down, your image becoming redder and dimmer as the light you emit struggles to climb out of the gravitational well. But for you, the experience is one of overwhelming brightness. The ring of fire that we see from Earth is actually the light of the accretion disk being magnified and bent by the photon sphere. From your perspective inside that ring, the heat and radiation would be blinding, a furnace of millions of degrees where matter is being crushed into plasma. This leads us to a disturbing implication that suggests our understanding of the outside of a black hole is a total illusion. If light can be trapped in orbit like this, it means that the black hole is constantly replaying the images of its victims. The frozen clone paradox we discussed earlier starts here. Information is not just a concept in a black hole, it is a physical layer. The photon sphere is the first step in the process of holographic encoding, where the 3D reality of an object is stripped away, and its data is flattened into a 2D shell. As you look at the back of your own head, you aren't just seeing a reflection, you are seeing the moment your existence begins to be translated into the language of the abyss. We once believed that the area outside a black hole was just empty space leading to a trap. Now we know it is a complex, multi-layered interface, a sentinel layer of magnetic fields, a scissor of space-time, and now a sphere of trapped ghosts. The photon sphere represents the boundary where your senses fail you. It is the place where you can look forward and see the past, where you can look into the darkness and see yourself. It is the ultimate warning from the universe that you have reached the limits of the observable world. Beyond this point, the light doesn't just orbit, it disappears. And as we prepare to move even closer, we must face the reality that time itself is about to do something far more terrifying than simply slow down. It is about to stop. We have reached the point where the light itself has given up. Just beneath the shimmering orbits of the photon sphere lies the most terrifying realization in modern physics, a place where the three-dimensional objects of our world are stripped of their volume and reduced to a smear of data. This is the 2D graveyard. Most people look at a black hole and see a tomb, a place where matter goes to be forgotten, but the deeper truth revealed by the holographic principle is that the event horizon isn't a wall of darkness. It is a cosmic hard drive. To understand this, we have to revisit the mind-bending conundrum known as the black hole information paradox. In our everyday lives, we assume that if we burn a book, the information inside is gone. But physics tells us otherwise. If you could somehow track every molecule of smoke and every atom of ash, you could, in theory, reconstruct every word on every page. Information in our universe is supposed to be immortal. The laws of quantum mechanics demand that it can never be truly destroyed. But for decades, black holes seem to be the one exception to this rule. They were thought to be the ultimate erasers, celestial shredders that deleted the history of whatever they consumed. But as we look closer at the interface, we realize that the universe has a fail-safe for reality. This is where the frozen clone paradox comes into play. If you were the one falling into a supermassive black hole like M87 star, your journey would feel relatively normal as you drifted through the interface. However, from the perspective of an observer watching you from a safe distance, something completely different and much more disturbing happens. As you approach that thin sliver of space just outside the horizon, your friend doesn't see you fall in. Instead, they see you start to slow down. Your movements become sluggish, your image begins to warp and stretch, and your light shifts into a deep, ghostly red. Eventually, to your friend, you appear to stop moving entirely. You become a permanent, motionless fixture on the edge of the abyss, frozen forever as a 2D image. You haven't just slowed down, you have become a fossil of information. This isn't just an optical illusion, it is a physical requirement of the universe. To satisfy the laws of nature, every bit of data that accounts for your existence, your DNA, the orientation of your atoms, the memories encoded in your neurons, must remain on the outside of the horizon. You are smeared across the surface of the black hole, flattened into a two-dimensional projection that contains the sum total of your three-dimensional life. This leads us to the law vault concept of the event horizon, acting as a literal 2D hard drive. In this graveyard, nothing is truly gone. Every star that has been shredded, every planet that has been vaporized, and every atom that has ever been pulled into the river of space has its information encoded on this surface. Think of the black hole as a massive library, where the books have been pulped and flattened into the wallpaper. The surface area of the black hole becomes a measure of its storage capacity. The more the black hole eats, the more its surface area grows, expanding to accommodate the new pixels of data being added to its record. This holographic principle suggests a reality that is far more unsettling than mere destruction. It implies that the three-dimensional objects we see around us, ourselves included, might just be projections of two-dimensional information stored at the boundaries of the universe. If a black hole can store the entire history of a star on its two-dimensional surface, then the outside of a black hole isn't just an entrance to a trap, it is the archive of everything that ever was. But there is a high energy price for this storage. This brings us to the firewall hypothesis, a theory that suggests this 2D graveyard isn't a peaceful place of rest, but a high energy barrier. Because the black hole is constantly losing tiny amounts of mass through Hawking radiation, the information on the surface is in a state of constant, violent tension. Some physicists believe that this interface is actually a blistering wall of fire that incinerates anything that tries to cross it, protecting the information on the outside from the matter on the inside. As you stand at the edge of the 2D graveyard, you are witnessing the ultimate act of cosmic translation. You are seeing the moment where the 3D world is cloned and translated into the language of the abyss. One version of you, the matter, falls into the center to meet the singularity. But the other version of you, the information, is written into the fabric of the event horizon, becoming part of the permanent record of the cosmos. The disturbing implication that most original videos miss is the permanence of this state. For as long as that black hole exists, which for a monster like TON 618 could be for trillions of years, your 2D clone will remain there, encoded in the light that never left. You aren't just a victim of gravity, you have become a part of the architecture of the universe's memory. The black hole hasn't just taken your life, it has archived your data, holding on to it until the very end of time when the black hole itself begins to evaporate. This leaves us with the most haunting mystery of the 2D graveyard. What happens to that record when the black hole finally dies? If the information is stored on the surface, and that surface eventually vanishes, does the universe simply delete the memory of everything that fell in? Or does the Hawking radiation carry that information back out into the void, a scrambled thermal message from a ghost that hasn't existed for eons? As we prepare to look even closer, we realise that the outside of a black hole isn't just where space breaks, it's where the very concept of existence is being redefined. The graveyard is full, and its walls are screaming with the data of 1 billion lost worlds. If the 2D graveyard was a psychological haunting, where your existence is reduced to a smear of data on a cosmic hard drive, then the region we are entering now is the physical nightmare that guards it. We have moved beyond the scissor of space-time and the visual loops of the photon sphere, descending into what scientists now recognise as the most extreme place in the known universe. For decades, we pictured the area just outside a black hole as a silent, cold void, a simple vacuum where things just drifted into the dark. But the newest, most detailed observations of the monster M87 star have shattered that illusion, revealing that the shadow's not unprotected. It is wrapped in a violent, invisible suit of armour, a sentinel layer made of polarised magnetic fields so powerful they redefine what it means for a black hole to eat. To understand the magnetic gatekeeper, we have to look at the light that managed to escape. In 2021, astronomers released a new version of the famous Ring of Fire image, but this time it was polarised. This wasn't just a filter, it was a map of the magnetic forces at work. What they found were powerful magnetic fields wrapping around the black hole's shadow in a structured, spiralling pattern. These aren't just stray forces of nature, they are the magnetic gatekeepers of the abyss. Imagine a colossal rotating wall of magnetism that dictates the fate of every atom approaching the edge. This sentinel layer acts as a high-energy barrier, and it introduces a terrifying possibility that many previous documentaries completely ignored: the firewall hypothesis. The firewall hypothesis is the ultimate collision between the two giants of physics, general relativity and quantum mechanics. According to Einstein's general relativity, if you are falling into a supermassive black hole, megin mofo onehawaimi, your passage through the horizon should be smooth and uneventful. You would simply sail through the interface without even realizing you had crossed the point of no return. But quantum mechanics, which governs the preservation of information, suggests something much more violent. Because the black hole is constantly losing mass through Hawking radiation, the information stored on the surface is in a state of constant, unbearable tension. To prevent that information from being lost or duplicated in a way that breaks the laws of physics, some scientists believe the horizon's actually a blistering firewall. A wall of high-energy particles and radiation that would incinerate anything before it even touches the event horizon. In this most extreme place, the magnetic gatekeeper and the firewall work in tandem to create a region of total annihilation. This isn't just hot gas, it is a furnace where matter is stripped of its identity. As the magnetic fields wrap around the shadow, they compress the incoming plasma of the accretion disk, heating it to billions of degrees. The radiation here is so intense, emitting constant bursts of X-rays and gamma rays, that it would be detectable from the other side of the galaxy. If you were to approach this magnetic sentinel, you wouldn't just be pulled in. You would be met by a barrier that dictates whether you are allowed to enter the dark or if you are destined to be blasted back out into the stars. This discovery reveals that a black hole is not merely a passive eater or a cosmic vacuum cleaner. Instead, it is an active engine of unimaginable power. These magnetic gatekeepers are the reason why black holes don't just swallow everything in their path. When the black hole chews on a massive star or a gas cloud, the magnetic fields act like a cosmic slingshot. They take a portion of that matter, accelerate it to nearly the speed of light, and blast it away from the horizon in the form of relativistic jets. These jets are so powerful they can shoot through entire galaxies, transforming the black hole into a quasar, the brightest object in the universe. Standing in the presence of the magnetic gatekeeper, you realize that the outside of a black hole is a site of constant high-energy warfare. On one side, gravity is trying to pull everything into the 2D graveyard. On the other side, the magnetic sentinel is struggling to push matter away, launching bullets of gas at a quarter, the speed of light back into the void. This interface is a high-energy filter that decides the future of the cosmos. The matter that is launched away by these jets eventually cools and forms the shockwaves that trigger the birth of new stars and solar systems, seeding the universe with the carbon and oxygen necessary for life. But for anything that remains caught in the magnetic grip, the end is swift and total. If you cannot be launched, you are destined for the firewall. In this thin sliver of space, just millimeters above the horizon, the magnetic fields are so compressed that they create a high-energy barrier that can incinerate matter into its most basic components before it is encoded as data on the surface. It is the ultimate gatekeeper, ensuring that only the information of what you were is allowed to enter the 2D graveyard, while your physical matter is consumed by the fire of the interface. This is the disturbing insight that changes everything. The outside of a black hole isn't just where you go to die. It is the most active, violent, and transformative engine in existence. We once thought we were looking at a hole in space, but the magnetic gatekeeper shows us we are looking at a sentinel. We are looking at a machine that uses a wall of fire and a suit of magnetic armor to guard the most precious thing in the universe, the information that defines reality itself. As we move past this sentinel, we leave the world of physical matter and fire behind, and we enter the place where the laws of time itself begin to shatter, leading us into the most famous contradiction in all of science. We have now reached the most disturbing crossroad in the story of the black hole, a place where the very concept of a single reality begins to splinter. Until now, we have discussed the physical destruction of your body and the bending of light, but as we step onto the event horizon itself, we must confront a mystery that challenges our most basic understanding of what it means to exist. This is the frozen clone paradox, a mind-bending conundrum where the laws of physics essentially force the universe to copy you. Imagine you and a friend have travelled to the edge of a supermassive black hole, like M87 star or Sagittarius A star. You have flipped a coin, and you are the one who will descend into the dark, while your friend stays behind in the safety of the spaceship to observe your final moments. This is the moment where time starts to break. As you move toward the event horizon, a terrifying divergence occurs. There is no longer one you. Instead, there are two separate journeys, and according to the laws of nature, both are equally real, yet they are fundamentally incompatible. From your friend's perspective, the horror begins as you approach the thin sliver of the interface. As you accelerate toward the horizon, your friend watches through a powerful telescope and sees something truly bizarre. Instead of watching you plummet into the abyss, they see you start to slow down. You appear to stretch and contort as if you are being viewed through a giant distorted magnifying glass. As you get closer and closer to the line of no return, your movements become increasingly sluggish, ticking away like a clock running out of batteries. This is the effect of extreme time dilation. To your friend, the gravity of the black hole is so intense that it is essentially stretching the time you're experiencing. They see your image begin to change colour, shifting from its natural hue into a deep, ghostly red. This is infinite redshift. The light reflecting off your body is struggling so hard to climb out of the black hole's gravitational well that its waves are being pulled apart, becoming longer and redder until they eventually fade out of the visible spectrum entirely. But the most haunting part of your friend's perspective is what happens at the horizon itself. They never actually see you cross it. To them, you reach the edge and simply stop. You become a permanent, motionless fixture on the boundary of the abyss, frozen forever as a two-dimensional image. You have become a fossil of information. In their reality, the heat of the interface, the firewall, or the intense Hawking radiation begins to engulf you. They watch in horror as you are reduced to ash, obliterated by the high-energy environment of the horizon before you ever have a chance to enter the darkness. To your friend, you are dead. You are a charred 2D smear of data on the 2D graveyard of the universe. However, if we view this scene from your perspective, the experience is almost nonsensical in its normalcy. As you drift past the event horizon, you feel nothing. Because you are in a state of freefall, you feel no gravity. You don't see your body stretching, you don't feel the heat of a firewall, and you certainly don't feel yourself burning to a crisp. You look back at your friend's spaceship, and you can still see them, though their image might look strangely sped up or distorted. You sail straight into the ominous black hole without so much as a scratch. One moment you're outside the universe, the next you are inside. How can both of these things be true? How can you be reduced to ash on the outside while simultaneously chilling on the inside, completely unharmed? This is the heart of the black hole information paradox. The laws of quantum physics demand that information can never be lost. Every atom and every memory that makes you you must be preserved somewhere in the cosmos. For your friend, that information must remain on the outside of the horizon to satisfy the laws of nature. If it simply vanished, the universe would break. Therefore, the universe creates a clone. It writes a copy of your information onto the surface of the black hole, encoded in the 2D shell we discussed in the previous chapters. This version of you is the one your friend sees, the one that is incinerated and turned into data. At the same time, the laws of general relativity, Einstein's masterpiece, require that you be able to cross the horizon smoothly, because to you the horizon isn't a physical wall, but just a coordinate in space. To satisfy Einstein, a version of you must enter the black hole. This is the frozen clone paradox. The universe has duplicated your reality to prevent a civil war between the two greatest theories in science. You are in two places at once, and you have two completely different fates. You are a 2D smear of ash on a cosmic hard drive, and you are a 3D traveller falling toward the singularity. The most unsettling realization of this paradox is that there is no way to verify which version is the real you. Because no signal can ever escape the interior of a black hole, you can never call your friend to tell them you survived, and your friend can never reach into the black hole to tell you that they saw you die. There is no paradox in reality because no single observer can ever see both versions of you at the same time. You can never compare notes. In this thin sliver of space, we find that the black hole is not just a destroyer of matter, but a scissor that cuts reality itself in two. It forces us to ask a disturbing question that original videos always miss. If the universe can clone you to save its own laws, then what are we? Are we physical beings, or are we just information that the universe can copy, paste, and delete as it sees fit? As you continue your fall toward the center, you aren't just leaving your friend behind. You are leaving the very idea of a single truth behind. You are a ghost on the horizon and a survivor in the void, caught in a visual and logical loop that will eventually lead you to the end of time itself. As we move past the fractured reality of the frozen clone, we arrive at a phenomenon that is perhaps the most haunting experience a human being could ever endure. We have established that for an observer far away, you appear to freeze in time, but what happens if you don't fall in? What if you possessed a spacecraft of impossible power? A magically insulated vessel capable of hovering just a single millimetre above the event horizon. In this thin sliver of space, you would not just be defying gravity, you would be stepping out of the stream of history itself. This is the billion-year hour, a region of extreme time dilation where the ticking of your watch becomes the metronome for the death of the universe. To understand the sheer scale of this horror, you must first visualize the river of space we discussed earlier. Because the fabric of the universe is being pulled into the black hole at nearly the speed of light, time itself is being stretched to the breaking point. Near a black hole, gravity is so high that time moves at a different pace than it does in the rest of the cosmos. The closer you get to the horizon, the slower your personal clock ticks. If you were to look at your watch while hovering here, a single second would feel like a second. Your heart would beat normally. Your thoughts would move at their usual speed. But as you turned your gaze away from the black hole and toward the stars you left behind, you would realize that the rest of existence has entered a state of frantic, terrifying acceleration. This is the time dilation witness paradox. Because you are at the very bottom of the deepest gravitational well in existence, the light from the outside universe is falling toward you, gaining energy and frequency as it descends. This causes a phenomenon known as blue shift, the opposite of the infinite redshift your friend sees. To your eyes, the distant stars wouldn't just be points of light. They would begin to glow with a brilliant violet intensity, their movements becoming a blur. You are effectively watching the universe fast forward. In the first few minutes of your local time, the ghost in the lens would begin to show you the end of human history. As you hover, you would watch the stars above you spin faster and faster, like a reel of film being played at 1,000 times its normal speed. If you looked back toward Earth, assuming your telescope could still find it, you would see the millennia flicker by in heartbeats. 10,000 years would pass in a few of your minutes, a time when the genetic differences of humanity have long since faded, and the very languages of your birth have become unrecognizable artifacts. By the time you have spent 30 minutes hovering in the shadows of the abyss, you would witness the true fragility of your homeworld. You would see the continents shift, colliding and tearing apart as plate tectonics dance across the crust like shadows. In what feels like an hour of your life, you would watch the sun's luminosity increase by 10%. From your perspective, the Earth's atmosphere would suddenly transform into a damp greenhouse, and the oceans, the cradles of all life you ever knew, would begin to boil and evaporate into the vacuum of space. You are witnessing the evaporation of the oceans as a brief midday event. The psychological weight of this billion-year hour is a detail most documentaries miss. You are a silent, immortal witness to the extinction of everything you loved. You watch as an asteroid, kilometers wide, strikes the Earth, igniting fires that make the air unbreathable. Yet to you, the resulting crater appears and erodes in the blink of an eye. You are effectively a ghost, standing just outside of time, watching the death of your home star. In a few more hours of your local time, the sun would run out of fuel, swelling into a bloated red giant that consumes the inner planets before finally collapsing into a cold, dim white dwarf. As the billion-year hour continues, the very structure of the night sky begins to change. The Milky Way galaxy, once a familiar spiral, would collide with Andromeda, merging into a chaotic, brilliant new shape before settling into a dull, elliptical haze. You are watching the universal cycle of creation and destruction play out in a single afternoon. Every star you can see will eventually run out of hydrogen, lighting up for a final time before fading into darkness. The universe you came from is essentially ending, and you are the only one left to remember it. But there is a final, disturbing revelation that occurs as you hover at the edge of the end of time. If you stay here long enough, perhaps just a few days in your reference frame, you will eventually witness the evaporation of the black hole itself. According to Stephen Hawking, black holes ain't so black. They emit Hawking radiation, a tiny thermal glow that causes them to lose mass over eons. For trillions of years, the black hole has been slowly shrinking, losing a tiny bit of mass with every particle that escapes. From your perspective, this process is no longer slow. Because time for the rest of the universe has accelerated to infinity, you would watch as the monster beneath you begins to glow with a blinding white heat. The black hole, which once seemed eternal, is now disappearing. And as the horizon finally vanishes, the 2D graveyard of information it held is released back into the void as radiation. This is the ultimate paradox of the interface. To escape the black hole by hovering is to run away from tomorrow, but in doing so, you have arrived at the end of all tomorrows. You have travelled through a one-way time machine to a future where the stars have all gone out, and the only thing left is the Hawking radiation of a universe that has long since frozen and died. You are left alone in a nice and normal space once again, but it is a space that is empty, cold and silent. We once thought the outside of a black hole was a place to explore. Now we realise it is a place where we go to witness the end of reality. You didn't just fall into a hole, you stepped out of the story of the universe entirely, only to find that when you finally tried to go back, there was no universe left to return to. You are a survivor of the void, standing in a trillion-year-old graveyard, realising that the billion-year hour wasn't a journey, it was a sentence. We have spent our journey focusing on the no-return zone, the place where light dies and information is frozen in a two-dimensional grave. But there is a massive misconception that has dominated our collective imagination for a century. The idea that a black hole is a perfect, efficient vacuum cleaner. We picture a silent, dark maw that swallows everything with surgical precision. The reality we have found just outside the edge is far more chaotic, far more violent, and, strangely, far more generous. Because as it turns out, black holes are incredibly messy eaters. In their struggle to consume the universe, they often end up vomiting a significant portion of their meal back into the void with a fury that can reshape entire galaxies. This is the phenomenon of the relativistic jet, and it transforms the black hole from a passive predator into an active, screaming engine of creation. To understand this, we have to look at the accretion disk, that swirling carousel of doomed matter we discussed earlier. As gas, dust, and even entire stars are pulled toward the event horizon, they don't fall straight in. Instead, they spiral, rubbing against each other at nearly the speed of light. This friction generates a celestial furnace, heating the matter to millions, even billions of degrees. In this state, matter is no longer a solid or a gas. It is a pressurized, electrically charged plasma, emitting a blinding storm of X-rays and gamma rays that can be detected from the other side of the cosmos. But here is where the magnetic gatekeeper we encountered in Chapter 5 takes control. As this superheated plasma swirls, it generates intense, polarized magnetic fields that wrap around the black hole like a suit of armor. For some matter, these fields act as a barrier, funneling it away from the event horizon before it can ever cross the point of no return. Instead of being swallowed, this matter is accelerated along the black hole's axis of rotation and blasted outward in two narrow focused beams. These are the jets, cosmic fire hoses that shoot matter into the deep vacuum at nearly a quarter the speed of light. We have seen direct evidence of this vomiting monster in a relatively small black hole located about 28,000 light-years from Earth. This object, weighing only 5 to 10 times the mass of our Sun, has been observed pulling matter off a companion star and belching it out in the form of massive, high-speed bullets of gas. These gas bullets are moving so fast that if they were heading toward us, they would cross the distance from the Earth to the Moon in a matter of seconds. When a black hole engages in this kind of high-energy feeding frenzy, it ceases to be a dark patch in the sky and becomes a quasar, the brightest type of object in the known universe, outshining all the stars in its parent galaxy combined. However, the most disturbing and beautiful insight found just outside the black hole isn't the violence of these jets, it's what they carry. We once believed that black holes were the ultimate destroyers, the end of the line for all life. But the deeper we look into the lore vault of cosmic history, the more we realise that black holes are the cosmic architects of existence. When a black hole collapses from a massive star, or when two of these monsters collide, they don't just erase matter, they forge it. In the high-energy crucible just outside the event horizon, the fundamental building blocks of life are produced and released. This is where oxygen and carbon, the very elements that make up your DNA, the air in your lungs, and the ground beneath your feet, are scattered across the universe. The black hole doesn't just eat stars, it acts as a cosmic seeder, using its relativistic jets to distribute these vital elements across thousands of light years. These jets act as a catalyst for star birth. As they blast through the cold gas clouds of a galaxy, they create massive shockwaves. These waves compress the gas, triggering the gravitational collapse that leads to the formation of new stars, new planets, and eventually, new solar systems. In fact, astronomers have observed black holes in dwarf galaxies lighting up stars that would otherwise have never been born, encouraging the growth and development of the entire galaxy. This reveals a profound irony that most outlier videos miss. We are the children of the abyss. The matter making up everything we are, every atom in our bodies, is thought to be a result of black hole activity in the early universe. Without these vomiting monsters to churn the cosmic soil and spread the seeds of carbon and oxygen, our solar system would likely be a barren, lifeless void. The black hole is not just a sinkhole in space, it is a heart, pumping the lifeblood of the universe through the veins of its relativistic jets. As we stand just outside the event horizon, watching these bullets of gas scream past us at a quarter, the speed of light, the perspective shifts. We are no longer looking at a predator, we are looking at a gardener. The outside of a black hole is a site of constant violent recycling, where the death of one star becomes the birth certificate of a billion others. But this realization brings us to a final, terrifying question. If the black hole is an engine that creates life, what happens when that engine starts to fail? What happens when the information it has spent eons collecting begins to leak out into a dying universe? To answer that, we must face the ultimate instability, the moment the black hole itself begins to disappear. We have spent our journey exploring the black hole as a permanent monument to the universe's power, a cosmic hard drive that archives the history of everything it touches. But now we must face a disturbing revelation that suggests even these eternal monsters are destined to crumble. For a long time, the scientific community believed that once a black hole formed, it was a one-way street. It would only grow, feeding on gas and stars until it became an ultra-massive beast like TON 618. But in the 1970s, the late great physicist Stephen Hawking famously determined that black holes ain't so black. He discovered that through a process now known as Hawking radiation, these titans are slowly, agonizingly leaking their mass back into the void. To understand the evaporation crisis, you have to look at the vacuum of space just outside the event horizon. In our everyday understanding, a vacuum is empty. But quantum physics tells us that the vacuum is never actually empty. It is a bubbling cauldron where pairs of virtual particles are constantly entering and exiting existence, appearing and annihilating each other in a fraction of a second. However, at the very edge of a black hole, this quantum dance turns into a tragedy. When a pair of these particles appears right at the horizon, one particle can be sucked into the gravitational maw, while the other has the opportunity to escape into space. The energy required for that particle to escape doesn't come from nowhere. It is paid for by the black hole itself. Every time a particle escapes, the black hole loses a tiny, infinitesimal fraction of its mass. On the scale of a human life, or even the life of our planet, this process is so slow it is almost imperceptible. For a black hole with the mass of 100 million tons, it would take the entire age of our current universe to lose just 50% of its mass. But in the billion-year hour of the far future, where the stars have all burned out and the galaxies have faded into cold husks, this slow leak becomes a death sentence. This brings us to the ultimate mystery of the outside of a black hole, the information crisis. If you recall our journey to the 2D graveyard in Chapter 4, we established that the surface area of the black hole is its storage capacity, a literal 2D hard drive where the data of every star, planet, and person that ever fell in is encoded. But as the black hole emits Hawking radiation and begins to shrink, its surface area decreases. This creates a terrifying logical contradiction. If the hard drive is shrinking, what happens to the files? For decades, this was the black hole information paradox that bothered everyone in physics. Stephen Hawking's initial calculations suggested that the radiation leaking out was purely thermal, meaning it was just random heat that contained no information. If that were true, then as the black hole eventually evaporated into nothing, every frozen image on its surface, every clone of a fallen traveller, and every record of a destroyed galaxy would be permanently deleted from the universe. This is the disturbing implication that original videos often miss. If a black hole can simply delete information, then the very fabric of our reality is a lie. The laws of nature are clear that information can be scrambled, but it can never be destroyed. If the outside reality we've been observing can simply vanish, then our own history, which may be encoded on the boundary of a higher dimensional black hole, could be deleted just as easily. However, in 2019, a series of groundbreaking papers suggested that Hawking might have missed a subtle detail in his original math. This new research suggests that the radiation is not information-free. Instead, it appears that the radiation is imprinted with the data of everything that fell in. As the black hole shrinks, the information stored in the 2D graveyard isn't being deleted. It is being translated into the Hawking radiation and carried back out into the universe. But this resolution only leads to a deeper, more unsettling question. If your information is carried out by radiation, what does that you look like? By the time the black hole is in its final stages of evaporation, it has become a microscopic pinprick of unimaginable heat and energy. In its final second of existence, it explodes with the force of millions of hydrogen bombs, releasing a final, chaotic burst of quantum ghosts into the void. From the perspective of an observer in the far future, the black hole has vanished, and space is all nice and normal again. But the universe is now filled with a scrambled thermal message from a ghost that hasn't existed for eons. The frozen clone that was once stuck on the horizons, and now a wave of radiation travelling through a dead cosmos. This is the evaporation crisis in its truest sense. It reveals that the outside of a black hole is not just a storage site, but a processing centre that eventually returns everything it took, but in a form that is unrecognisable. We once thought black holes were the ultimate end, the place where the story of matter stopped. Now we see them as a universal cycle of creation and destruction, where the black hole sucks everything in, only to eventually spew it back out as information-rich radiation. But as the last black holes in the universe begin to pop like soap bubbles, leaving behind nothing but a thin haze of Hawking particles, we're forced to confront the final revelation of the interface. If the black hole can hold the entire history of a star on its 2D surface, and then rebroadcast that history as it dies, what does that say about the nature of the space we are standing in right now? We have looked at the shadow, the fire, and the ghosts. Now it is time to look at ourselves. Because the ultimate secret of what happens just outside a black hole isn't about what is happening there. It's about the terrifying possibility that it's already happened here. We have spent this journey descending through layers of fire, magnetism, and shredded time, always looking inward toward the darkness as if the secret were hidden at the centre of the void. We treated the area just outside the black hole as a mere foyer, a dangerous waiting room for the inevitable end. But after years of searching, the ultimate revelation is not what lies at the bottom of the pit. It is the realization that the outside is not just an entrance. It is the entirety of the universe's record. For decades, our focus was on the singularity, the point of infinite density, where the laws of physics scream and then fall silent. We assumed that the inside was the destination. But the holographic principle and the discovery of the 2D graveyard have turned that logic inside out. If every star, every planet, and every moment of history that ever fell into a black hole is encoded as a two-dimensional smear of data on the event horizon, then the inside is practically irrelevant. The interior is just a shadow, a mathematical consequence of the information stored on the surface. In a very real, physical sense, the true reality of a black hole is its outside edge. It is the cosmic archive, a hard drive that stores the data of the universe long after the physical objects have been pulled like a fabric into the singularity. This leads us to a disturbing symmetry that changes everything. If the black holes inside our universe are two-dimensional record keepers for everything they consume, what does that say about the universe we inhabit? Scientists have noticed a cool exercise in mathematics. If you take the total mass contained within our cosmic horizon and calculate the density, the result matches perfectly with the Schwarzschild radius of a black hole that size. We aren't just like a black hole. Our universe possesses the exact mass-to-volume ratio of a black hole's event horizon. This coincidence suggests that our Big Bang wasn't a random explosion from nothing, but a Big Bang singularity that mirrors the birth of a black hole. Some theories, like those of Nikodem Poplawski, suggest that our entire universe originated from a seed of matter compressed to its maximum inside a black hole in a much larger parent universe. When that seed reached its critical limit, it didn't just collapse, It burst forth as a white hole or a daughter universe on the other side of the interface. This creates a universal cycle of creation, where the death of a star in one universe becomes the birth of an entire cosmos in another. But the most haunting evidence for this revelation is written in the very spin of our galaxies. In our everyday lives, we expect the rotation of stars and galaxies to be random. Some should spin left, some should spin right. However, recent studies of hundreds of galaxies have hinted at a net rotation, or a net angular momentum to the entire universe. In one part of the sky, research has found that the majority of galaxies spin to the left, while in another part, right-hand rotation prevails. This shouldn't happen in a random explosion. It only happens if our universe inherited its swirl from something else, like the toilet bowl style, angular momentum of matter spiraling into a parent black hole. We are carrying the fingerprint of the monster that birthed us. This brings us to the final hook, the one that forces us to look at the stars and see not a vast expanse, but a boundary. Could our entire 3D universe actually be a 2D outside layer of a higher dimensional black hole? Imagine a massive star in a 4-dimensional space, a world we cannot even perceive, collapsing into a 4D black hole. Just as the 3D black holes in our world have 2D event horizons, a 4D black hole would have a 3D event horizon. In this model, our 3D world is effectively the accretion disk, or the interface of a 4D monster. We aren't living in the center of a world, we are living on the outside edge of something else entirely. Everything we see, the galaxies, the light of the photon sphere, the very fabric of space-time, might just be the holographic projection of information stored on a higher dimensional shell. The mystery of what happens just outside a black hole has finally been answered, but the answer is more terrifying than the darkness itself. We spent years looking for a hole in the universe, only to find that the universe is the hole. We are the frozen clone, the 2D record of a history being processed by a sentinel we can never see. We are the data smeared across the boundary of an abyss, a visual lie told by the failure of physics. Standing on the precipice of this revelation, we realised that the black hole wasn't just a predator in the dark, it was a mirror. By looking at the outside of M87 star, we were finally seeing the structure of our own existence. We aren't the protagonists of a vast, 3-dimensional story. We are the footnotes on a 2D shell, a fossilised record of a 4D collapse that happened eons ago. The ghost in the lens isn't just a black hole 53 million light years away. The ghost is us. After years, we finally found what happens just outside a black hole. Everything. Everything we've ever known, every star that ever burned, and every universe that will ever be born is just a thin sliver of data on the edge of a higher dimensional void. The mystery isn't what's inside, it's that we've been living on the outside of the abyss all along, and the shadows we've been chasing were actually our own reflections.